Welcome to the 20th Better Buildings by Design Conference. Congratulations, 20 years. That's fantastic. I'm Karen Glitman. I'm the Director of Efficiency Vermont. And I want to give a special thanks to our keynote speaker, Dr. John Straube, and to the workshop presenters, moderators, attendees, and especially to the Efficiency Vermont team that has worked for the past year to help organize this conference. Thank you, Efficiency Vermont staff. The Better Buildings by Design Conference is important to Efficiency Vermont because we can only succeed in our mission to promote energy efficiency in Vermont with your partnership. Each year, we convene this conference to offer building trade professionals like you access to leading experts in the energy efficiency and building performance fields, to showcase the latest residential and commercial building products and services, to offer technical workshops to expand your qualifications and expertise, and to allow you to network with your peers. A skilled workforce is critical to Vermont's economy as a whole, and it is also critical to delivering energy efficiency to Vermont customers. According to the 2017 Vermont Clean Energy Industry Report, 19,000 Vermonters' jobs are clean energy related. That's 1 in 16 working Vermonters are working in the clean energy sector. That's a tremendous impact. Of those, nearly 6,000 full-time jobs are associated with energy efficiency services. That's a lot of people, and that's all of you. Energy efficiency works because of you. The energy efficiency utilities can bring new technologies and products to market, and they can provide the services to drive customer demand. But it's primarily building professionals that meet this demand and deliver the positive customer experiences. It takes a lot of Vermonters to make energy efficiency work. A recent project up in Orleans County with the county government really brought this home for me, how we all work together to improve the lives of our customers. Now, if you drive through Newport, you get to see the town. And maybe if you drive a little too fast, you might get to see the inside of the county courthouse. See, that did work, Jeff. Better yet, just stop in sometime and have a look around. The project has turned a drafty, damp basement that was home to a healthy spider population into a warm, cozy, usable space where employees can relax during their lunch break. It's now also a safe storage space for the county's many historic photos and other memorabilia that are now protected from mold and rot. Spray foam has sealed the leaky 130-year-old stone foundation. Steam pipes have been wrapped to reduce heat loss. LED bulbs now illuminate the windowless space. And a brand new heat pump water heater has been installed in place of a less efficient old electric unit. If you move up to the ground floor as you walk through the offices, you'll see heat pumps and bright, efficient LED lighting. What you won't see anymore are electric space heaters under the desks, which were a regular fixture just weeks ago. They're not needed anymore. In the grand main courtroom on the second floor, you'll see a high chandelier with a dozen bulbs. Replacing the lower bulbs requires a climb up a ladder. And for the highest bulbs, a special lift has to be brought in. Now, with long-lasting LED bulbs, it will be years before anyone has to climb a ladder again, which results in a significant safety and maintenance improvement for the county. And the light quality is improved and energy use reduced. A programmable thermostat is helping to keep the room at a comfortable temperature only when it's occupied, helping to further reduce the heating bill. The abandoned fireplaces in each corner of the courtroom have been sealed with inflatable chimney bags, purchased at the local pick and shovel store just down the street. The Pick and Shovel, by the way, is one of Efficiency Vermont's retail partners. There are plenty of reasons to visit Newport, and the Pick and Shovel is just one of them. The technology and products I mentioned only work because of the people that make the project so successful. It took a lot of Vermonters to make this happen. It started with visionary legislators and regulators who created the nation's first statewide energy efficiency utility back in the year 2000. They saw the value of scaling up energy efficiency to become a statewide resource for all Vermonters, regardless of zip code. They understood the value of transforming markets and igniting the supply chain from manufacturers to installers to achieve our shared energy and economic goals. Now fast forward 18 years to today, to a project that started the way so many do, with a customer, in this case, Mary Ann Fletcher, a motivated county treasurer and lifelong Northeast Kingdom resident. She is committed to making county taxpayer dollars go farther and to protecting the environment. She reached out to a trusted contractor to scope out a lighting project. The trusted contractor in this case was Mark Longtine of Newport-based Gates Electric. Mark is a member of the Efficiency Vermont's Efficiency Excellence Network and an employee of Gates Electric for 15 years. Mark and his business partner, Don Rondo, bought the business this past June. He advised Mary Ann of the incentives and support that might be available through Efficiency Vermont. Soon, Mary Ann was in touch with Efficiency Vermont account manager Mark Kelly. Mark visited Mary Ann to get an understanding not just of the lighting needs, but the broader opportunities the county had to save energy and to save money. Mark enlisted the engineering expertise of Nicole Duquette, a UVM graduate and energy consultant at Efficiency Vermont. Nicole analyzed the building systems, recommended improvements, and ran the careful calculations to estimate the 57% energy savings the county could expect, and the cost for achieving it. The products and measures Nicole recommended were available in the Vermont marketplace, and that's thanks in large part to Efficiency Vermont program designers like Jenna Puglisi. Jenna and her team have been working for years with manufacturers, distributors, and retailers to apply the upstream, midstream, and point-of-purchase incentives. This work has resulted in efficient products being available to Vermonters at prices that are competitive with less efficient alternatives. With the project now defined, incentives and resources mobilized, and a motivated customer ready to facilitate action, it was time to bring in the skilled local workforce of contractors to correctly install the new equipment and upgrades so they would deliver the promised energy savings, comfort, and other benefits of a well-designed and implemented energy efficiency project. Contractors on this project included Nate Therian of Fred's Energy of Vermont, based in Derby, Mark Longtine of Gates Electric, based in Newport, Mark Nadeau of Nadeau's Plumbing and Heating, based in Newport, Jim Ryan of the Newport office of the Northeast Employment Training Organization, and Buddy Chapman of New England Foam and Coating, based in St. Johnsbury, and also a 2018 BBD exhibitor. Some of these contractors are here today, expanding their knowledge and expertise for the benefit of their Northeast Kingdom customers. In tandem with the courthouse, we worked at the County Sheriff's Department's building in nearby Derby. Between the two projects, the county will save an estimated $8,400 a year in energy cost, and these savings will attribute back to the taxpayers in that county. The Orleans County project is just one of thousands that Efficiency Vermont and our trade allies have done together over the years. They've come in different shapes and sizes, from weatherizing homes all the way up to major retrofits at some of the largest commercial energy customers in the state. The scale of the projects vary, but they are all based on the partnership with a skilled workforce of contractors, designers, and architects with the know-how to get the job done right. Year after year, you have stepped up to provide the services and expertise necessary to make customers' energy efficiency projects a reality, learning new skills and techniques to make sure Vermonters have access to the state-of-the-art in energy efficiency. It has been and continues to be a beneficial partnership. Together, we are a powerful force for improving Vermonters' lives, reducing energy use, and saving money, protecting the environment, and supporting the economy. In 2017 alone, Efficiency Vermont's partnerships with 918 contractors, 148 building design firms, 801 equipment suppliers, and 313 retailers have resulted in 15,500 businesses served for a combined lifetime savings of more than $106 million. More than 106,000 households served for a combined lifetime savings of more than $80 million. Nearly $250,000 have been saved by low-income Vermonters, and 840,000 tons of carbon dioxide emissions have been avoided. That's about what a forest the size of Rhode Island can sequester in a year. That's a lot of savings for a lot of folks. In the process, our partnership has contributed substantially to the creation of the more than 19,000 clean energy jobs in Vermont. The stronger we make this partnership, the more value we can deliver to Vermont businesses and households. And in that spirit, I'd like to take a few moments before we move on to announce the best of the best award winners to hear from you. This is that live polling we talked about. As many of you know, our clean energy future requires continued investment in energy efficiency, deployment of new technology, training more workers, and deeper knowledge of integrating demand and supply side resources. Today, we are kicking off what will become an annual live poll to get the pulse of our industry. Where are we doing well in progressing towards this future, and where are we falling short? So if you can, please take out your cell phone, and hopefully John had you all ready to go to move forward. And if you haven't, to join the poll, send the following text message to 22333, EVT poll. Folks all joined? We'll do a test run to begin with. You'll get the confirmation message. Two things: your responses are anonymous, and standard text messaging rates do apply. All right, so let's do a quick warm-up question. We got to clear that result, unless someone's already started. So I like to start my day off with A, just the basics, cereal and milk. B, coffee, and more coffee. C, the blue plate special, ham, eggs, potatoes, and whatever on special. And D, whatever I can grab as I leave the house. So you can see how this is working. We've got 60 results, 77, 79, 84, 104. And the battle is on between coffee and whatever I can grab. And at some point, we're going to say we're going to close the poll. Give it a few more seconds. 136, 138, 140, 141. All right. Folks understand how this is working? You see it? Yeah. All right. I think people want coffee. So there's coffee down in the exhibitors throughout the day. You'll be able to get it there. All right, so now let's move on to a more substantive question. So the next question. Yeah. I forgot something. Oh, yes, I was supposed to make sure. The EVT staff are, if you could not comment, so as not to skew the results. So all of you that work for Efficiency Vermont, if you could please refrain from answering. Okay. So for those who are watching on Facebook Live, so I can read these questions because they can't see it unless I read it. What is your primary reason for attending the Better Buildings by Design conference? A, training, professional development. B, networking. C, the exhibits and emerging technologies. Or D, other. Got 140 results in. It looks like the training and professional development is the winner. 163, 164. Right, for that's under other, right, for the coffee. All right, so I think we got a pretty clear sense here that the training and professional development is the most valued aspect of the BBD conference. All right, next question. Which of the following terms most closely matches your profession? So trying to understand who's in this room. A, contractor. B, design professional. C, distributor, supplier. D, government agency or an NGO. E, facility sustainability manager, or F, manufacturer? So it looks like we're pretty split between contractors and design professionals. Design professionals have just, it's going back and forth there. It's like a horse race. All right. So I'm going to say that we're basically split between contractors and design professionals. All right. 40% each. That's great. Okay. So next question. Describe the financial outlook for your company in 2018 compared to 2017. A, I expect our profits to increase. B, I expect our profits to remain flat. C, I expect our profits to decline. Saw this as the optimist, pessimist, or neutral perspectives. All right, a lot of optimists, people feeling positive about the future. 73% expect it to increase. All right. That's great. Okay, so that gives us a pretty clear sense. People are feeling very positive, 30% remaining flat and only 7% declining. Okay, next question. Which of the following would best support your business's growth and financial stability? A, fewer regulatory and permitting hurdles. B, increased consumer demand. C, less competition. D, more available, well-trained workforce. Or E, more working capital. That's going back and forth, more demand, more workforce. Between consumer demand and well-trained workforce, with consumer demand taking a solid lead as it comes around the bend. And all right, I think we've got a pretty good sense that that consumer demand is a real driver, but the trained workforce is critically important as well. All right, next question. What is the biggest barrier preventing you or your company from pursuing more training? A, lack of relevant training opportunities. B, limited interest in receiving more training. C, lost work time or time in the field. D, inconvenient training locations. Or E, inconvenient training time. So it looks like the lost work time is a big factor, an overwhelming factor at 73%. With very few, okay. So I think I'm going to say we're good. We know it's lost work time, but the lack of relevant training opportunities at 25%, so 56% lost work time or time in the field. All right. And do we have one more question? Yes. When hiring for a new position, where do you typically find skilled labor? A, from your competitors, which I'm not sure how friendly that is. B, online job sites. C, state-sponsored programs. D, recommendations from colleagues. Or E, trade schools, colleges, and universities. So the recommendations from colleagues is at 48%. 51, that seems to be the strongest and clearest place, with online job sites and trade schools trailing that. With 9%, 10% taking them from their competitors. Okay, 11, yeah. All right, so do we have one more question, John, or was it? Okay. So that's the last question. Thank you. So we have a great deal to celebrate, and thank you for participating in that. I hope that was fun and a great way to get feedback from a large group of people in a short period of time. So we have a great deal to celebrate as we look back, and we have a great deal more work to do as we look forward. So thank you all for being here. So we're going to be moving on to the Best of the Best Awards. So every year, Efficiency Vermont uses Better Buildings by Design as an opportunity to highlight some of the best design, build, and renovation projects from around our state. These winners exemplify the integration of innovative energy efficiency practices with durability, beauty, and practicality. I'd like to take a moment now to recognize this year's winners. And if you can please hold your applause to the very end of the award presentations. So in the category of residential new construction, the honor award goes to the Central Vermont Habitat for Humanity, Chris Mixchick of Montpelier Construction, Bruce Landry of 5-Star Energy Tech, and Tolya Stornorov of Stornorov Workshop for the Habitat for Humanity Passive House in Montpelier, East Montpelier. The Merit Award goes to Shelterwood Construction and Kaplan Thompson Architects for the Lindbergh Home in Waitsfield. The Affordability Honor Award goes to Vermont Homes for the Bennett Home in Duxbury. The Affordability Merit Award goes to Stewart Construction, Vermont Integrated Architecture and Engineering Ventures for the Bristol Co-Housing Apartment in Bristol. And the Residential New Construction Partner of the Year goes to Nancy and Alan Benoit of Sustainable Designs. In the category of Home Performance with Energy Star, the over $12,000 Honor Award goes to Vermont Energy Audits for the Keeler Home in Greensboro. The over $12,000 Merit Award goes to New Frameworks Natural Design Build for the Milliken Home in Charlotte. The under $12,000 Honor Award goes to the Energy Co-op of Vermont for the Moore Home in Burlington. In the category of Commercial New Construction, the New Construction Major Renovation Award goes to the Smith Alvarez Sienkiewicz Architects for the Vermont National Guard Vehicle Maintenance Shop in North Hyde Park. In the category of Multifamily New Construction, the New Construction Major Renovation Award goes to Duncan Wisniewski Architecture for Elm Place in Milton. And the Commercial New Construction Partner of the Year goes to Wyman Lamphere Architects of Colchester. So congratulations to all of our winners, and can please stand for a round of applause. All right. And on more than one occasion, I have heard Dr. Straube described as the energy guru. He has been requested many times as a keynote speaker by previous BBD participants. John is a principal at RDH Building Science, where he heads forensic investigation and leads research projects in the area of low energy building design, building enclosure performance, hygrothermal analysis, and field monitoring of wall assemblies. He is a faculty member in the School of Architecture and the Department of Civil and Environmental Engineering at the University of Waterloo. His leadership as a building scientist and as an educator has been recognized with multiple awards, including the Lifetime Achievement Award in Building Science Education from the National Consortium of Housing Research Centers, and the Professional Leadership Award from the Northeast Sustainable Energy Association. Please join me in welcoming Dr. Straube.
Hit that away.
There we go. A little set change.
Good morning, everyone. It's quite nice to be here. And it occurred to me, I heard that this is like the 20th, I guess, example of Better Buildings by Design. I think I was here in 2002 for the first time. And so this morning, walking around the halls and such, there were many familiar faces and even a handful of friendly ones that I recognized. Most of the friendly ones were the ones who haven't seen me before. My keynote today, we talked a little bit about what, and so we kind of decided a little bit of everything. I don't have any sort of inspiring, uprising change and call to action, because in many ways, and I was speaking to Peter Temple of Keene State University last night, a lot of the revolutionary ideas are actually, we've made them, at least to the 20% of people who show up at Better Buildings by Design conferences. There remains I would say, 75, 80% of the marketplace who still thinks flashing's a lewd act, and insulation is something you do because you have to. But at least the people in this crowd, the people who are exhibiting here, understand a lot of the things we have to do. And I think we're moving into a phase where we just got to do it. And there's a lot of grinding it out, worrying about the details. But there are some exciting things in our future. There certainly are changes in our future, because one of the things that we are pretty certain is that tomorrow is not going to be exactly the same as today. So I'm just going to talk in the context of building science and technology a little bit about change and future trends, and then pick just 3 topics to delve into, which are continuous insulation, prefabrication, changing housing types, and then end with a rapid case study of cool new technology. So what is changing, and again, this is merely a trend line. There's not these massive step changes, but obviously retrofit's a big deal, and Efficiency Vermont has been on top of that since their inception. And that is also because, look, if you were in Denver in 2000, it was possible to believe that the only game was building new stuff. Whereas that was not possible to deceive yourself if you lived in Vermont in 2000. You'd realize that there was a history and a culture. And when I see that county house being renovated, I see it as much of preserving a history and a heritage as it is about making it more energy efficient and comfortable. And there's a lot more of the country that needs to do that. And of course, the Northeast being one of the older parts of the country, retrofits, upgrades, and changes are going to be a continuing and growing trend. One of the good news stories is I think people now recognize better than 20 years ago that actually really deep retrofits are worth it. And it's not based on energy savings. It's based on you get a new building that's actually got some style to it and meaning to it. And you don't pay for it all with energy. You're going to retrofit it anyway because it's worth retrofitting. The changing and aging population is, again, something that will be more impactful in the northeastern United States than anywhere else. And that means that we have a larger percentage of people who need assisted living. I have a grab bar in my hotel room. I don't think they particularly thought that I was handicapped. But the reality is that we are all handicapped for large parts of our lives. Until we're what, 8 or 10? Some would argue mentally until you're 25. And then by the time you're, in your 40s, you start getting handicapped again. And so having a grab bar is probably a good idea. Luckily, I wasn't drinking last night and didn't need it. But I could have. And so changing our housing to reflect these types of changing populations is also an ongoing trend that's just going to accelerate. We're going to see more and more infill in existing cities, which is a whole different animal when compared to production builders. So again, in 2000, a lot of work was being done in the production building world, where people who were building one house after the other, and how do we get the last savings out of that? We're talking people who are today building production houses in the $75 a square foot range for production product. Yeah, but you can't do that if you're building in an old lot in a small town in New England. That's just ridiculous. And that part of the market, which was small in 2000, is growing today, and it'll grow more. We're going to bulldoze fewer farms, and we're going to revitalize more cities. Doesn't sound like a bad trend. We're also seeing this move to granny flats, in-law suites, accessory dwelling units, to use the passionless label, that we're starting to see changes on. And we're seeing a lot more mid-rise buildings, which it used to either be you got a 2-story or you got a 20-story surrounded by freeways, and now we're seeing the sense in terms of your community planning and demographics of having the 3 to 6-story. Multi-use was a time in America where Well, we had zoning maps, and if it was green, you could put residential, and if it was blue, you put commercial, and there's no frickin' way we're gonna put those two together because that would be mixing colors. And now we're actually going back to incentivizing that. I mean, literally, how many towns in Vermont always had, you know, a retail on the ground floor and apartments above, and then we went through the 80s and 90s where that was just verboten. I mean, that was just crazy. And now we're going back to common sense, and that is changing, and that changes how we design, how we inspect the materials and trades and systems we have to use. And we also see, or maybe I've just become aware of, tremendous regional variations. When I'm advising on a project for an infill housing project in San Francisco, we are talking about lot prices per housing unit in the order of $100 to $1 million. If you're talking a small 400 square foot bedroom, 400 square foot no bedroom studio, that's a $100,000 land price. If you're talking about a townhome, that's $1 million land price. Well, that completely changes how you design and build relative to working in Topeka, Kansas, where we're doing an infill where the lot costs us nothing if we were willing to tear down the existing house. And if the house is already teared down, you can buy a 70-foot lot in Topeka that's fully serviced, walkable to the downtown core for under $20,000. So that changes how much you care about insulation, mechanicals, energy efficiency, et cetera. And so there's a huge diversity in America that wasn't there as much in the past. And it totally changes when you read a magazine or you hear a vendor selling you a product. It's like, well, where's that market? Is it a downtown Chicago market or is it rural Atlanta? You know, there's a very different answer, and that means we're having divergent solutions more so than we have in the past. Now, these are the changes that are happening sort of demographic, socially, economically, but there's also the demand side from the consumer saying, yeah, we want lower energy buildings, but more importantly, we want more comfort. That's actually a bigger driver, and of course, energy you can do calculations on and predict the numbers and payback. Comfort is, what, priceless, depending on whom you're speaking to. And so people will spend a lot more money on comfort and health, better indoor air quality. How much is it worth to not have your children cough up blood? I'd put a bit of money into that. And so people might actually insulate their basement floors not to save $82 a year in energy bills. It's so that the kids can crawl around on a carpet without dust mites and mold. And that should be worth some money. And so we still haven't made that shift in the industry. We're still saving purely energy savings and not doing enough of the actually, how about just a good building? I'm sorry if it saves energy because it's a good building, but how about just push towards a good building? We want to build things quicker because we're impatient. All the economic arguments are bullshit. Interest rates are not driving the need to build our buildings faster, et cetera, et cetera. It's that when people make a decision, they'd like the outcome because the world is rapidly changing and uncertain, and they want to make sure that their decision remains valid in that short time period. And because we build quickly, we build all the time. There was not that long ago a time where people knew that February was not a good time to build foundations. That time apparently has long passed. And so now we have like electric heating blankets, and we consume thousands of gallons of propane thawing out dirt so large, powerful equipment can dig through frozen ground so that small, less powerful humans can freeze their bikinis off while they try and put formwork in that hole. But that is what it is, and so now we're saying there's a real drive to making products, systems, and techniques that allow us to build in February, in January, in the middle of the heat, and not actually have performance problems or productivity problems. And of course, we always want higher labor efficiency, or maybe we just want construction laborers to have a good quality of life like other people, so that they can actually work normal hours and not end up having to retire at 52 with bad hips. And so that means that we're changing how and what we're willing to build, what risks we're willing to take. So some of this stuff results in more practical, down to the ground demands, is that we have more insulation. But realistically, the codes are starting to change to realize it's not just about insulation, it's about how well it's installed, and it's how well you do it without thermal bridges. And we kind of knew that in 2000, 2002, but it wasn't as obvious. And at that time, we were still telling people, look, you got to put more insulation in. I mean, it was a no-brainer, just more insulation. Today, more insulation isn't always a no-brainer. 95% of the time it is, right? But, there are people who are building houses with, literally 16 inches of insulation in the wall, and it's like, well, maybe that's not the best environmental decision to make. Maybe there are other choices. Well, that's a pretty profound tipping, although I would say it's still a small percentage, but that tells us what's coming, is that we're actually going to start deciding that we might not want that much insulation, and airtightness is the same thing. Obviously, most of our buildings need to be more airtight, including new ones. But, once you're at 0.5 ACH 50, how much benefit is there to 0.3? Do you really want to flush your toilet every time you slam the front door? So it creates other, resource consumption issues. And one of the trends that we knew were around in 2000 was that we had more airtightness and hence blower doors to show that. And we still have a ways to go, and it is, to me, the thin edge of the wedge of being able to reliably deliver performance. So we know we need air tightness, and the blower door was an inexpensive and simple way to demonstrate to everybody that we achieved that. And the feedback loop to trades and materials and technology was massive, and that's why we now generally have a good feel about how do we get below 2 ACH 50, and even how we get below 1 is because of the feedback loop from thousands of blower door tests. But we need this equivalent of a blower door test for drywall cracking, of water penetration, of air quality, and we need ways to assure ourselves and our clients, and the owner needs to be assured that we are delivering what we say we are. And so far, it's mostly been based on trust. Yeah, the drywall won't crack. No, when there's a flood, it won't run into the basement, et cetera. But we don't have ways of demonstrating that we're actually delivering. And so more work on quality assurance and quality control in all aspects of building performance is needed, and it'll probably take a long time to develop and deploy those techniques. Now, one of the things that's very big in the news, and particularly if you work at a university like it's all about innovation, right? It doesn't matter. It doesn't help to solve problems. I mean, this is annoying as an engineer. You say, well, but I'm supposed to solve problems. No, you're supposed to be innovative. And again, the condemning words come, the construction industry, it's slow to change and conservative. Well, it bloody well better be slow to change and conservative. These are the largest investments most individuals ever make in their life. Oh yeah, let's just jump on the last trend. Let's switch to something that has a 5-year timeline. When you buy a smartphone, it's okay to make the wrong decision. It's a few $100, and it has a design life of 3 to 5 years. Okay, you can get a new one. If you build the wrong city, it's really freaking expensive. And the other thing about innovation is that we have to think of the time cycle. I mean, how long are the decisions we're making, are they going to be stuck with? We don't want to make quick changes for products that are supposed to last 75 to 150 years. There's a lot of pure, rational, good decision making that goes into being conservative. Now, that shouldn't be mistaken to saying we're not making changes, but then I think it would be a misrepresentation of the building industry to say we haven't made changes. For those of you who have been in the business for 40 or so years, you probably, if you look closely, will realize we've changed an awful lot over 40 years. There are new products and systems like low-E coatings and spray foam or how about latex paint? How common was latex paint in 1987 versus how common it is today? There's vastly different ways of building and materials of building, but it looks similar, and so the outsider says, oh, we're a stodgy and conservative business, as opposed to walking around the exhibitors and saying that pretty much everyone's got something new pretty much every year. It doesn't mean we're all rushing out to buy it, like the new iPhone, like drones with no mentality. We actually have to put it in context of, is it appropriate? Yes, we need new products, but we don't need all new products. And something that's really important about innovation in my world is that innovation is not just something that's new. It's supposed to be something that's better. It's supposed to solve a problem. And too much of the breathless media forgets that. And of course, that's what drives state programs and universities, et cetera, is that they read the media and believe it. And we need to be more reasoned and less passion-driven than that. Now, the technology has improved a lot, and I think it will improve more. And if we think about the things about photovoltaics and LEDs, 18 years ago, 20 years ago, PVs, they were stupidly expensive. You were better off buying diamonds to put on your roof than PVs. And now we're at the point where photovoltaics, the panels are so inexpensive, it's basically putting out solar hot water out of business because photovoltaics is cheaper, which is something I never thought I would say. And actually, in places like Boston or San Francisco or Chicago, the relative cost of insulation to the total cost of a built product has plummeted. It's like, we did some rough calculations to demonstrate this to a multi-family housing developer, but in the San Francisco area, insulation was almost 10 times less expensive as a proportion of the sold product as it was in 1985. The insulation hasn't got any cheaper. Everything else has gotten more expensive. And so, as I often say about insulation, it's dirt cheap, except that, a group like this, somebody told me, is that, have you actually priced dirt? And so I have after that, and it's actually more expensive. And so most insulation is actually less expensive than dirt, and yet it is the #1 thing that builders and developers focus on. Oh, what's the ROI of the cheapest fricking product in the building, and one of the few that actually can save you money over the lifespan of the building? And so that mentality is still busted, but people like this group are aware that it's worth it and we don't ask too many questions. It's just we do some insulation. But there's still that 75 of 80% of the unwashed masses who still think that fluffy stuff costs money. So if we need innovation, I would say a lot of it has to do with more the mechanical heating, cooling, ventilation, and hot water systems. There still seems to be a disconnect between the needs and what's being provided to the marketplace. We've seen a revolution in the availability of practical and affordable heat pump technology. We still don't have great cold climate, non-natural gas-based hot water heating systems, and that is a growing load because the other loads are dropping. We need better ventilation systems because when we put them in really airtight buildings, we have a problem now with running exhaust fans and clothes dryers, and we don't have a good solution. Although we can conceive of them, they're not available in the marketplace. And what we probably don't need is to have our fridge speaking to the internet. That is what the industry is offering us. Yes, my furnace is connected to my iPhone, and that makes the world a better. These are problems that people have invented to create solutions that actually create a problem. And so, that's not the kind of innovation we need. Would you, go back to your design offices and come up with actual solutions to actual problems as opposed to a web-talking fridge? Now, one of the things that we had been pushing for years because of our better buildings, more airtight, better insulated, and smaller, are smaller furnaces. And after literally 15 years of pushing, we have a product on the market that finally is actually, 15,000 BTU an hour peak furnace. That's 95% efficient, low electrical use, et cetera. One product. And of course, it's not from any of the major suppliers. At least we don't have to import it from Swaziland or something like that. But it is made from close. It's made in Quebec. But at least it's closer to home. And I'm assuming the major players in mechanical systems will eventually get their heads out of their butts and provide products that are needed for the new generation of buildings. But that's the kind of innovation we need. It's not a new invention. It's just build the product that people need in quantities of more than 3. So as we look into the future, as I said, we need more quality assurance. We're going to see more prefabrication or off-site construction. Definitely going to see more net zero energy buildings, but the problem is it doesn't solve the problem. Sure, net zero energy is the way we're going to go forward, but the real problem in terms of energy and carbon and energy security is about existing buildings. So yeah, net zero, but the bigger challenge is everything else. And one of the things about the everything else is that there's not as many easy cookie cutter solutions. And so it does rely on a lot more local knowledge, a lot more boots on the ground in that town or township. It's not going to be somebody from San Francisco designing the retrofit for the Vermont legislature. It's got to be somebody in Vermont. So in the three topics I wanted to quickly cover, continuous insulation. 15, 20 years ago, in 2002, when I gave my presentation on high-performance walls, of course, I said you should put insulation on the outside. And even then, that wasn't radical to some people. I'm looking at Andy and Mark. But, you know, they weren't normal people. I'm looking at Andy and Mark. But slowly, lots of people have embraced it, but it's still a hard go. I'm amazed at how difficult it is, even though it's in the building code in, say, California, to have people put insulation on, and on the outside. It's really quite bizarre. And so there has been lots of investigation now and lots of demonstrations and tests on different ways to get to higher R. So we started with this basic 2x6 wall, and the building science answer in terms of durability, flexibility, climate adaptability is don't put any insulation in the structure, whether it be concrete, steel, or wood. Just wrap the entire thing with insulation and then put whatever cladding you want. That's the building science answer. It's not the only answer. And of course, we're going to be modifying for price and project. And so the other answer was sort of, let's do more of the same instead of, like we went from 2x4 to 2x6. Well, now let's go 2x8, 2x10, 2x12. That eventually seems kind of stupid, so we split the studs in half. And so because we can't build one good wall, we build two kind of okay walls and put them together, and you get the double stud wall. Totally works. Been using it now since the 80s. It's just not as good as the other way. And I don't know that we're going to see any fundamental breakthroughs in physics or materiality that makes it better or equal. It just means that, look, if you really want a piece of wood to nail your siding to, that's, I guess, the answer. That's the leftover reason as to, I think, why people do it. That and underpaid carpenters. There's two reasons to do it. I want to attach vinyl siding to a piece of OSB I can see, and I don't pay my carpenters very much. Now, we also have interior insulation solutions, and those are important, of course, primarily on the retrofit side, even though the same answer of exterior insulation is really the deep answer. We're not going to do that in a historic courthouse or city hall. That's just not going to happen, so we have to come up with solutions on the inside. Definitely some room for innovation there, although a lot of the early uncertainties are past. And I was interested to see the spray foam on the inside of the basement of that case study project this morning, because, you know, in 2002, that was pretty ridiculous, putting spray foam on the inside of the concrete foundation. It's like, ooh, I'm sure the building's going to go away. But now people have gotten to realize pros and cons. It's not crazy. You know, there's just some things you got to watch for. So a lot of maturity there. And then, of course, the compromise is sort of a split solution, and that particularly works well in wood stud systems, which is why it's kind of more the mass market. It has most of the building science benefits of an exterior insulated wall. It's more similar in construction to what people are used to, and so it sort of splits the difference. Now, so we all know this, tried, tested, and true, and increasingly you're not able to build this unless you do energy modeling to show that you can waste energy here and make it up somewhere else. The exterior insulation is a drawing that's been around for a long time. In Canada, Ontario, to be more precise, this was one of the solutions in the 1986 building code change, but only one of them. The other solution was thicker walls, but this was a solution then. And thicker walls have been around since at least the Saskatchewan house, 1980, in the prairie provinces. There it's been popular because it's dry. And so they've gotten away, the moisture sensitivity can easily be managed. And now we also have other examples for multi-story buildings where we can have non-combustible insulation to improve the fire resistance when we're building 5-story buildings, but exactly the same strategy as what we started with foam on the outside. So although research and experience have shown that it works, we really still seem to find that there's a lot of a lack of awareness out there. And I don't know what it takes because there's oodles of documentation, and it's all on the internet, which I think we all know is 100% true. And the uncertainty stems from things like vapor, but people still worry about foam insulation trapping moisture in walls. Well, it does, unless you do it the way it's supposed to be done. Wetting and drying, cladding attachments, the whole idea of furring strips and so on still seems to be a bit odd for many people. We recently finished a project started in 2012 for the Canadian government because the code is changing that we're going to have to come up with significantly better insulated walls. And so these are all supposed to achieve well over R30. So that will probably be next code cycle. We're going to get close to R30 as a minimum requirement. And on the left, you see the 3-inch stone wool, 2.5 inches of extruded polystyrene, and 2 inches of polyiso. Those are all over a 2x6 frame, have an equivalent R12-ish on the outside as exterior sheathing. And then on the right, we have the standard wall, 2x6, an I-joist wall. Why an I-joist? Well, that's how you can make a thick wall and spend lots of money on framing. So it's a twofer, right? And to be honest as to why did it come up, well, nobody in North America would invent that because we actually can do math and know what it costs. But it came from Sweden, so it must be good, right? And even some of the Germans are copying the Swedes, so that's like, holy shit, why even check the price? I mean, let's just do it. And then the double stud, which is comes out of our really low energy pass from the 80s and the passive solar, et cetera, and to show, let's see how that works. So this is just a slide to show the effective R values, the basic 2x6 wall in the R18.7 according to our building code.
Can I see your passport? We need you to make an announcement. There are a lot of cars parked in the fire lanes, and they're going to start towing them. Sorry for interrupting.
Anybody who's parked in a fire lane, shame on you, and you need to move because they're going to tow you shortly. And I don't know if you tow around here or push, because in our parts in the wintertime, it's usually pushed with the snowplow, so because it's more available. So it does more damage, just pointing that out. So this is a couple of money shots of research here. The moisture content on the north side, so least sun, worst spot. Relatively high interior humidity, but airtight. And you can see the blue and the red are the double stud wall and the I-joist wall. The moisture content of the sheathing, of course, goes highest because the OSB is on the cold side of the wall. Even though it's airtight, there's enough moisture in the wall but it's not damaging, right? It's not dangerous. We're only talking 16, 18%. However, it means that we don't have as much reserve capacity for screw-ups. And so, let's just say we built it when it was raining and we built extra moisture in, or we had a leak at the window or things like that. We have less safety. The polyiso and the extruded polystyrene foam walls are shown with the orange and yellow. They show a little bit of a spike during the coldest part of the winter. It happened late in February that year, but we were having like below 0-degree nights. And so because they had no poly and only R12 on the outside, they started picking up some moisture, but not a lot. And the stone wool wall is stupidly boring, and it runs along at 6% moisture content because both it can dry very easily to the outside and it has exterior insulated sheathing. So you get to pick your risk factor here as to which level of risk are you in terms of use and what your owner wants. Then we added a calibrated air leak. Now, air leaks don't occur in a calibrated fashion in real life, but we put a calibrated air leak in so that each of the walls saw exactly the same quantity and quality of air injected at exactly the same spot. So that's fair comparison. And you'll notice the moisture contents get higher here. The green line is your standard 2x6 wall. And when air leaks out in a 2x6 wall, yeah, you get condensation on the OSB. You bet you. But it dries out really quickly as soon as it warms up. By warms up, I mean it goes to, say, 20 degrees. And already that OSB is drying out, and you can see those lines bounce up and down. So not a lot of time spent wet. Particularly, they only spend a lot of time wet when it's really cold, so not really a problem. When you look at the blue and the red, again, the double stud I-joist walls, they get wet and stay wet. They do dry out when we get to warmer weather and stop air leakage, but it takes a bit longer. And the walls with exterior insulation, because they're insulated, they don't have air leakage condensation. And so this is not new. This is a story building scientists were saying in 2002. But we actually set up an experiment so that we could actually show the numbers, so it's not just a matter of science and opinion and experience, because why would anyone believe in science, opinion, and experience? And so we had to measure some walls to say, look, we're actually measuring this stuff, and what science, experience, and opinion says is happening. So this is when we open up the walls. It's unfortunate that the OSB was a darker color going in, but you can see at the sill plate that that is beautiful wood. Despite the fact that it got to 20-some% moisture content in the OSB, there's a little hole there where we sampled the OSB for mold, and the moisture content sensors all said it got wet, but it doesn't get moldy. So wood is thankfully more forgiving than people give it credit for. And so even at those moisture contents, the walls look pretty darn good. This was the polyiso wall. Again, really no sign that this, after 4 to 5 years, that this was not a pristine wall. Everyone would be happy to see it. So even with those warning signs of moisture content, that doesn't mean that the walls are going to shit. That's the technical term. So another trend line that really is taking off, and if we want to add some excitement. So exterior insulation is exciting if you're from California, because it's about as exotic as a UFO. And if you're in New England, you might need something more interesting. Well, now we see off-site construction or prefabrication, whether it's panelized, modular, or component-based, as being something that's much more common. And so this is an example of, to me, a bad example of a modular home construction site going together. I'll explain in a moment why there's, just looking at it, it makes me worried. But this is the idea of panelized, prefabricated off-site construction. And so, you know, the famous line of these proponents is that it just clicks together like Lego, which is, of course, utter bullshit. Because Lego with blocks that are like 10 by 30 feet that weigh 3 tons and dangle from an 80-foot cable in the wind. Exactly like Lego. And it comes together with come-alongs and sledgehammers and hydraulic jacks and curse words, exactly like Lego. So it's not like frickin' Lego. It's like large modular building components with dimensional variations that have to be managed. So the Lego analogy is really harmful because it makes people not pay attention to the things you have to pay attention to. Lego also doesn't mind if it gets rained on. Wood does. So we are promised more labor efficiency, higher quality, reduced weather sensitivity, reduced cost, reduced waste, better sex life. Everything comes from off-site construction. Now, the challenges in practice tend to be the joints between the units. They need to be carefully designed and executed because you get one chance to stop the outside from going to the inside when you do modular construction or panelized construction in the enclosure. So that means you got to design it. In fact, the challenge here is that it's not hard, it's just you got to plan early. You probably should do like a mock-up, try it out. And people seem to think it's just like, oh, I'll just draw this detail and I'm sure it'll work, and off we go. And it doesn't, that's when we see problems, forensic issues. And they come from partly dimensional control. And this is, of course, brought about by things like SketchUp and Revit's BIM and all that, where buildings are actually straight and square. Do you know what buildings aren't? Straight and square. And so we actually draw foundations, and then we make cubes, and they actually drop on top, and they all line up. But that's not real. It's a simulation of reality. The only question isn't, is the box straight and square? It's how non-straight and how non-square is it? Once you accept that it's not straight and square, actually a lot of the problems go away. Just design for it. We recently built a hotel in the far north where they have 12,000 heating degree days. Insulation's not hard to sell there. And they actually are built prefabricated units in Shanghai at a temperature of around 77 degrees. They are being installed in a temperature of something like between 0 and minus 20, because it's spring. And that means that the 42 to 48 foot long modules were about half an inch shorter when installed than when they left the factory. Right? Now, it's even worse than that, though, because you can fit them all together. But what happens when you actually turn the heat on in the modular building and it now goes up to 72 degrees and it grows half an inch? What gives? The steel core, or the connection, or the joint, or the window? Short answer, pretty much all of those things in varying degrees. So those are the kinds of issues that we don't have to deal with as much when we're assembling on site, and they accommodate, and we have a lot of experience about how to accommodate dimensional tolerances and movements by standard practice. So we can't pretend that this is exactly the same. It actually requires more experience and smarts. It's worth it. It just takes effort and planning. And transportation and erection moisture problems are a growing issue. As we see more and more prefab, we see more and more during construction problems with moisture, especially rainwater. So none of this stuff is that new. We've been doing modular housing construction since the 30s in pretty large scale. We had Project Breakthrough in the 60s. The US government sponsored a massive project on modular housing, especially multi-unit, multi-family buildings. So we know this stuff. It's just that we want to pretend that it's easy because the past tells us it's hard. We've long prefabricated windows. You know, they used to build windows on site, and they don't anymore. The same thing with stairs. You notice that they don't build a lot of kitchen millwork on site anymore. How many boilers do they actually assemble on site anymore? Right, all of that stuff has been prefabricated off-site for, now it's on to decades, so we forgot that it used to be done on site. But we started and were successful. They have two things. One, high value per cubic yard or per ton, and two, mass production. That we can make the same furnace 1,000 times. That we can make the same kitchen 100 times in details with only small changes in dimension. And so now we're moving into areas where there's lower value per cubic yard, lower value per pound, and where there's less repetition. And so that means we have to be smarter. Now, I'd like to think we are smarter, but we can't forget that it takes effort. So I point out that this was 1920s pre-cut systems. In the 1920s, many manufacturers of housing systems said, we got it solved. We've got this whole manufactured thing solved. And by the 1940s, almost all of them went out of business, and by 1950, they all were out of business. And what was the invention of the 1950s? Was to do industrialized manufacturing on site. That was Levittown. That's how we started building subdivisions. It's like, don't build the building in a factory and ship it. Have the people move from site to site because they're easy to move. Whole houses are difficult. And that's what the paradigm we lived with for the last 50 years. Now that paradigm's falling apart for a bunch of reasons about weather sensitivity, labor availability, the kinds of housing forms. And so it's not surprising that more panelized and prefabricated modular type construction is coming back. But another ingredient's also necessary. in almost every case, panelized and modular is more expensive. And you need to have more expensive buildings and land to justify that, or you need to have really expensive access to site, say downtown Boston. Just getting things to site, staging yards, et cetera, means that the premium you pay for modular is totally worth it. Or far northern Canada, where you can't find people, you have a short building season, sure, it's worth the premium. And that's what happens. So when we talk about panelized systems, which get less press because they're less exciting, but we've been doing them for a long time, right? Precast concrete panels, curtain walls that are unitized, and wood systems have been panelized for decades, and quite successfully. Now the challenge is that when you build panelized, you got a base system, then you add the walls. That wall is exposed to the weather. If it rains right now in this cycle, the inside's going to get wet. So then I put up the other panel. Finally, when I put the lid on, maybe I can start finishing the inside and adding interior partitions. But that interior partition now has a hard time being dropped into place because I got the lid on. So you have to make some choices, and it's all about the weather sensitivity and the ability to make an interior finish. But these types of systems have been widely used. I think I was involved in one in 1984 when I was still an undergraduate student or high school student, thinking about becoming an undergraduate student. And our construction site had prefabricated eaves with steel studs. Building still works. With the modular process, you actually ensure that you can do the interior because you've protected the interior with a roof. The problem is that that roof may also just be a ceiling, and so you have a duplicate ceiling, which drives up the cost. And you're shipping mostly air. On a volume basis, mostly what you're shipping is air, and that's not really a lot of value. It's available on site. Really, do we need to ship it from the factory? But if it makes up for enough job site inefficiencies and schedule inefficiencies, we do it. So it's ideal when we're doing repetitive units and remote locations or downtown city cores, but as we get more flexible kind of arrangements that aren't rectangular boxes, and when we're looking for using an established trade in suburban sites, really hard to compete. So this is from a case study in Oakland, California. And here's a module being flown in. That is actually the building on the bottom right is being assembled out of units like that. Now, one of the things that you should be aware of is that if it were to rain right now, that building would get really wet. And so you can see how effectively the Tyvek is being installed there, flapping in the breeze. I guess it's getting a little bit of a blower door test, even that's why it's flying along. And of course, when you look at the sky in the background, you think, maybe it is about to rain, right? Okay, it starts to rain, so we'll stop setting units, so we wrap everything up in plastic, and of course they do it really perfectly when they wrap it up. And you can see, man, walking around, do you think they got a leak? I don't know, what do you think? And this is what happens when people don't give this stage of construction enough attention. And this is the same project. That's the roof. You can see blue tarps held down with concrete blocks. And you know how that'll work just great, right? Yeah, that's perfect, yeah. And so there's the water coming through the collapsed drywall ceiling on the left. And on the right-hand side is when they had to remove all the drywall because, in California, they don't really like mold. A lot of lawyers, stuff like that. And so then they have to rip out the inside. So, seriously, just this one rain event and any potential cost savings were all completely gone. One rain event. Now, and what are the odds of it raining when you're building a 200-unit, 6-story building? So there's nothing but optimists in this business. So here we have a different project. This is in British Columbia, where at least everyone knows it's always raining. And so this actually is a wrapped modular unit, and it's like heavy marine plastic, the stuff you store your boats in over the winter. And they do that at the factory before they push it into the yard. They don't even wrap it. They have a wrapping station before it goes out. It sits in the yard, and there's red tape in the corner there, which every time they lift it, they have to cut through the plastic to get to the lifting hooks, and after they've moved it from the yard to the truck, they tape it up again. drive it down the road at 60 miles an hour to do a bit of a rain test. Then they have to cut it open, lift it off, often to a staging spot, because apparently the trucks don't arrive precisely in the 5-minute window that they plan to lift the crane into the space. And so they end up often having to leave it stuck there. Although it's cheaper to rent flatbeds, right? Just say, rent 10 different extra flatbeds and park them, don't take it off. Anyway, then when this is about to be lifted into place, and now is when they cut the plastic off. But this is that unit installed, and it actually has a welded metal roof, a metal ceiling to provide water protection during construction. But you can see that the joint in the middle there that's indicated is not watertight, because there's 2 units that come together. So where we help them with this, and on the left-hand side you have the exterior house wrap coming up, and water, of course, just runs behind it. So our, this was a photo, literally was sent to us. We circled it up and said, you're going to have problems here, here, and here. And they're going, no, we know that. That's why we called you. But I guess now that you identified where the problems are, we will hire you. So we actually identified, no, you can't do that. And so they had to come up with a strategy of when that box is set, literally in the next 20 minutes to half an hour, you need to seal that. And now we have to specify materials that'll stick to wet steel, or in a Keynote, stick to frozen steel. And there are products available like that. In the extreme case, such as a Keynote, where it was wet and or frozen at any given time, it was mechanical retention bars that are screwed tight to an EPDM membrane. And of course, does that increase the cost? Yeah, $300 a box, they tell us. And was that worth it? Absolutely. But it has to be thought through. So that's why, as we move, you can see this is a project we did, RDH, is a passive house project. And you'll see the sides are completely wrapped in a fully adhered air and water barrier. Not because we need it in service, it's because we need it to survive the construction process. Because what are the odds of it raining during installation? In Bella Bella, 100%. So changes in the kinds of housing is also one of the reasons that we're seeing this stuff. So multi-unit housing, walkable cities, more accessible homes for an aging population, and we probably should stop calling it multifamily, because more than families live in these buildings. And that is a demographic change that matters. In fact, they're mostly not families. U.S. Census facts, people who live in multi-unit residential buildings are more than 50% not families. They're couples, they're empty nesters, they're singles, they're urban professionals who are not connected, etc. Friends with benefits, they're all living in these multi-unit buildings. And so they're not multifamily anymore. That's like 1950s Leave It to Beaver technology. So what this does as we build more multifamily, particularly when we build them out of new technologies, is we have to learn new ways of getting fire and sound separation between the units and air tightness separation between the units. And normal wood frame construction, we don't have that. So it's a lot of technology and a lot of on-the-ground tradecraft needed to be able to deliver that. And renovation and retrofit, I mentioned, it's not a new housing type, but it's a pretty big deal. And it is already now, I think it's cracked 50%. It has in Canada. I think U.S. is a couple years behind. In 50% of spend on residential construction is now in repair and retrofit of existing buildings. Whereas if you track that number from the 60s and 70s, it was like 75, 80% of money was spent on new. So it's continuing to happen. And so this huge stock, when we're renovating it, retrofitting it, repairing it, we're not just making it more energy efficient. We've got to be making it healthier and safer and more comfortable and more usable. And people will pay for all of those features. The fact that it's energy efficient is the gravy, not the steak. The steak is a better building. The energy is the gravy. And of course, the challenge is there are all kinds of different buildings, and when we change them, we change them. And that means we have to think about airflow, water, wetting, drying, fire. How have we changed this building? We want to change everything neutral or better. We don't want to do things that are worse. And that's tough, and we need a lot more understanding of that and a lot more dissemination of knowledge on that, because there's so many different building types, from single-family 1920s to multi-1980s to 1860s courthouses. I mean, there's like all that technology is so vastly different, we need different techniques that has to be trained. Accessory dwelling units are a growing thing, driven by state and zoning laws being changed to allow existing buildings to plug in, this is a version of infill, into existing infrastructure. It's one of the best ways to get affordable housing, increase density, and strengthen the community. And actually, on the right-hand side, we have one of the local champions, Bright Build Homes, and they have recently had this in-law suite, I think they call it, which I think, interestingly, you put PV on that, and now that's how you get your photovoltaic supply now it's 2 households, though, which manages the grid stress a little bit. On the bottom left, this is basically a net zero ready modular unit. You can see they didn't hire Kaplan architects to design that one, but it is cheap, and it's made in California, and it's because they've changed the rules to force municipalities to allow such accessory dwelling units. And that is some of the lowest cost housing you can come up with that's healthy in California, is an ADU. So those are going to be changing technologies and types. So I'm just going to, last 10 minutes or so, go through a case study of tall wood that incorporates some of these experiences. And we've seen wood being pushed into bigger and taller buildings. That's one of the new things, right? That's, if you want to get lots of architects to show up at a seminar, you say you're going to talk about tall wood, something new, not how to do what they're doing, but something new. And tall wood is one of those things. And so we've seen a bunch of new products be developed. Most of us are aware of glulam, but that's so 1970s, no one's going to come for that. But CLT, or cross-laminated timber, sort of like plywood on steroids, where instead of using laminations of 1/8 of an inch, you use them of 3/4 to 1 1/4 inch solid timber laminations, and you build big planks that are like 8 by 40 feet, something like this. Nail laminated timbers, even newer, but also even older. Many mill buildings in the 10s, 20s, and 30s were built with 2x4 and 2x6 on edge, nailed, solid. Well, we can now do that quite cheaply in a factory and sell you a big slab of wood, the size you want, of nail laminated. And now we have dowel laminated. If you don't want steel nails in your floor, then I don't know why you don't, but let's say you don't, you can get dowel laminated lumber as well. So we're seeing this being used in a lot of these multi-family, multi-unit residential buildings where they're in emerging neighborhoods. We're building higher density, 5, 6 floors. This one's a CLT building. Those floor slabs are solid wood. This is a Minneapolis office building. This one's using nail laminated timbers. It snows in Minneapolis as well. And you can see the wood floor there is actually nail laminated timbers with glulam columns. And that's actually a relatively sizable building to make pretty much all out of wood. You'll notice the core is concrete, and that's not an uncommon thing to get the structural resistance. And it's a pretty good place to keep fire code officials happy that people can run into the stairs there and they know that that works. So, of course, when you build large buildings out of wood, you end up with new risks. And one of the risks that we've discovered is that, again, construction moisture. Much more of a deal than it used to be. Because when the water runs between these chunks of wood, it goes in easily, but it doesn't come out easily. And so you can actually have a lot more sensitivity to decay and rot than if you were to build it out of standard nominal 2x lumber, which is never further than 3/4 inches away from a free surface to evaporate. And many of you must have seen rot around windows and such, where you put 3 or 4 pieces of wood together and suddenly things don't work so good. Now, can you imagine if you put 8 feet of 2x6s and 2x8s together? It gets sensitive. And so it's been a hard sell, but as more and more forensic examples owners are starting to spend more effort on construction moisture management at the beginning. Here's a client who didn't, but mostly this worked. I won't dwell on the moisture problems they had, but just as an extreme example of this, this is an 18-story, sold as an 18-story wood building. Why? Because it's cool to say that, because people go, holy shit. It's actually not really. It's a concrete core with steel connections with a wood floor and column. Oh, and now steel stud wall system. So it's all the materials, actually, but they sell it as wood because that's cool. So this was, again, concrete cores were being used to provide lateral resistance and fire egress. The wood was the columns and the floor slabs. The floor slabs were topped with 2 inches of concrete for sound and fire performance. And of course, the building is sprinklered. This is the start of the building. You can see the concrete podium, and then the core takes off, waiting for the wood components to show up. There's the glulam columns being erected. And now the floors, they attach these big angles to the concrete core. And of course, they're welding them in place so that we can get dimensional tolerances. Because the person who did this didn't draw it on SketchUp and believe it. And so every steel angle had 3/4 inches plus or minus adjustability, and the easiest way to do that structurally in this case was with welds. There we dropped the CLT floor panel on top. Here you see it going in at the columns, and that's kind of what it looks like. You'll notice there are black tape lines on the floor. Those tape lines are there to stop the rainwater from flowing through to the floor below. It's also kind of shiny because the top surface had been coated with a water repellent after they didn't want to, but after 6 floors, they wanted to. And so then the remaining floors were coated with elastomeric coatings and taped. And when they didn't do the tape, they had all kinds of water running through the joints, and they had to put up, little kiddie pools, run out to the local store and buy a bunch of kiddie pools to capture all the rainwater. And so then the tape didn't seem that expensive anymore either. But it's really hard to tell people this is going to happen because they've never done it before. They think it's going to work perfectly. It helps to be a cynic. The wall panels were entirely panelized and done and in the factory. This shouldn't be news, but I think that's absolutely what's going to happen in the future. One of the reasons I think that we have so many all-glass towers in our cities is that the only companies that are out selling panelized systems are the window wall, curtain wall people. And so when you suggest using something that is actually energy efficient, durable, and maintainable, like a wall with a punched window, they're going, yeah, but I need it in a panelized system. And so these companies are emerging, although it still tends to be sort of a customized system, but there are increasing numbers of national brands who'll say, I'll sell you a panel with a punched window. It just hangs on your building like any other system. Thermally broken cladding attachments, stone wool on the outside, the panel cladding with a printed image of wood on the outside so it looks like a wood building. It's sort of like the station wagons of the 70s. People buy it. I don't know what to say. Here you are. There are each of the stations, and then windows are installed horizontally and stacked and ready to go. And then around the entire building, just an angle is installed. Again, why? Dimensional tolerances. That angle allows you to adjust the in and out to the nearest 1/8 of an inch, although the panels were designed for 1/4, and the height was designed for again, adjustable for the angle, nearest 1/8, with the panel adjustable up to 3/4. And then the panels are lifted off the truck, open panels, because it's going to rain during installation. 18-story building. What are the odds that one day you're going to have a panel that gets rained on? 100%. And so here they are being clipped on the side. You can see the continuous insulation on the exterior, full membrane, and there's a lot. This went through a number of mock-up stages. We built full-scale versions, installed it on a 2-story frame. shook it seismically, sprayed water at it, et cetera, and the building still came in at under $200 a square foot. In British Columbia, which ain't cheap. And so one of the these are the vertical alignments between the panels above and below, and you can see the slotted angle holes there that allows the panel height to be adjusted. No rocket science, but somebody's got to spend real hours. This is not just switch to panelized. Here's the joints using, in this case, a silicone product because it has the most durable type of chemistry. And then the inside, also between the vertical joints, have to be sealed as an airtight barrier with caulking. And so here you see the open floor, the beautiful mountains of British Columbia in the background. There will be new changes and demands. We are going to have to change more about our housing forms, respond to increasingly demanding expectations, and be better at reliably delivering what we say we are. But it's not going to be some sort of profound, oh, they're going to come up with a cheaper insulation. You can't come up with a cheaper insulation. It's already stupidly cheap. That's not going to revolutionize. Oh, they're going to make insulation that's R10 Who cares? Won't change much of anything. That's not the problem we need solved any more than an internet-connected furnace. But we do need to build on the knowledge and experience that we have. And again, this kind of a conference, been coming for many years. There's a lot of people who know a lot. But we are going to have to use that knowledge and experience and tweak it to meet these new changes. It's not a radical shift. It's a constant improvement, and there's a bit of a grind to it that we still have a lot of things to learn. There are new products coming along. We have to train people. I did see a 3-year-old attendee here, which was heartening to me because I think that's about the right time to start. And certainly waiting until people are graduating high school is way too late. We have to get people, 5 to 7 to recognize what we do is cool shit. And more importantly, it's meaningful. It actually matters to the people around us. And so that's sort of a challenge for the future, is that there's a lot of gray hairs or no hairs in this audience. And if we're going to do another 20 years, we need a whole bunch of people who know this stuff, care about this stuff, and are able to do this stuff. And so we have to put some emphasis, I know I'm biased as an educator, we have to put some emphasis on training that next generation up. Thank you. Very attentive. Appreciate your time.